Everyone, this is the continuation to the last video on shear in prestressed concrete members. To determine the shear, to determine the shear in prestressed concrete members at any point is given as tau v is equal to shear force times first moment area Q divided by moment of inertia times breadth of the section, where tau v is equal to shear stress, V is equal to shear force, Q is equal to first moment of area, and I moment of inertia, and B is the breadth of the member, breadth of the section. In first year of BTech, we studied about the first moment of area. The first moment of area, generally it is a measure how far an area is located from the axis. Q is equal to product of area and perpendicular distance from centroid to the centroid of the area to the axis, right? Want to determine the moment of area of the rectangle section about the base axis, then the formula will be area B into H multiplied by the distance from axis to central axis, H by 2. Then the formula will be BH square by 2, base square by 2. Like that, you can determine the moment of area for various section. We will take another example. Suppose for rectangle section, I am going to measure this moment of area of this rectangle section from base point. Now area of this one will be half into base into height, and centroid, the distance between the centroid to the axis will be H by 3. Then this is BH square by 6, base square by 6. Like that, we can determine the moment of area for various sections. Generally, in our in our problem, we will take the central axis about the neutral axis. Okay, while solving the problem, we will see. Already we know how to determine the moment of inertia, and this is the B means breadth of the section. As we discussed in earlier video, in beam there will be a variation in normal stresses and shear stresses as well, due to the various due to the combination of normal stresses and shear stresses. There will be a possibility to develop the principal stresses. These biaxial stresses may develop. These biaxial stresses can be determined by using the Morse circle theorems, right? Suppose if you want to determine the principal axis on pure shear state. Pure shear state means there is only shear, then there is only shear on this system. There is no axial forces on the system. In this case, we already discussed this maximum principal tensile stress will make an angle with axis 45 degrees, right? In that case, 2 alpha is typically 90 degrees. When there is a prestressing force, P, in that case there will be an additional axial force act on this element, and this angle increases and makes an angle greater than 45 degrees, and this 2 alpha is also greater than 90 degrees, right? In this case, we may have pure tensile forces. There is no compression. This we discussed in earlier video, right? We will if you want to determine if there is a biaxial forces, in most of the general cases, an element is subjected to two-dimensional stresses like shear and direct stresses. In the general cases, the elements were subjected to both shear and direct stresses. In this case, if you want to determine the maximum and minimum principal stresses, there is a formula: Fx plus Fy by 2 plus or minus half of root of Fx minus Fy whole square plus 4 times of shear square. This is the formula to determine maximum and minimum principal stresses developed by the both shear and direct stresses, right? In general, there are 3 ways of improving shear resistance of structural concrete members by prestressing techniques. First one, horizontal or axial prestressing. Second one, prestressing by inclined cables, and third one is vertical prestressing or transverse prestressing. By using these 3 techniques, we can improve the shear resistance in the structural members, right? By using these formulas, we will try to determine the shear strength of the member, and also we will compare the magnitude of principal tension developed by the beam. As I said, due to the combination of these 2 stresses, there will be a possibility of principal stresses. If the maximum principal tensile stress develops, there will be a crack, right? Due to the combination of shear and direct, maximum principal tensile stress may develop, and maximum principal compressive stress also develops. We may call it as a maximum principal stress, minimum principal stress, right? Maximum principal tensile stress or maximum principal compressive stress may develop. Due to the maximum principal tensile stress, there will be a cracking, and due to the maximum principal compression test, there will be a crushing of concrete in the member. Right? I am repeating again. Due to this shear and axial forces, there will be a possibility of principal stresses. In these principal stresses, there are two types of principal stresses: maximum principal tension tensile stress, maximum principal compression stress. This maximum principal tensile stress will develop cracks. This maximum compressive stress will develop crushing of concrete. Right? That's why we need to take care of these two. But here I'm concentrating much on to reduce the cracks due to shear developed by maximum principal tensile stress. Right? Now we will solve a problem. A prestressed concrete beam of span 10 meters of rectangular section. It is a rectangular section, 120 mm wide, 300 mm deep. It is axially prestressed. Means eccentricity is remains same. Axially prestressed by a cable carrying the effective stress 180 kilonewton. The beam supports a total UDL of load, 5 kilonewton per meter. Which includes self weight plus live load both. Okay, it is a combination of dead load plus live load. Question is that compare the magnitude of principal tension developed in beam with prestress, without prestress. We need to develop principal tension with and without prestress. Okay. Please understand the question. There is a prestressed concrete member of rectangular section. Width is given, depth is given, and span is given as 10 meters. It is carrying an UDL load of 5 kilonewton per meter. And now we need to determine the principal tension with and without prestressing force of 180 kilonewton. What can we do here? We know the formula for maximum and minimum prestress. F max is equal to Fx plus Fy divided by 2 plus or minus half of root of Fx minus Fy whole square plus 4 times of shear square. This is the formula. There will be only shear without prestressing force. Means it is a pure shear case. Then F will be 0. Without prestress means F will be 0. That's why this total term becomes 0. Fx 0, Fy 0 means 0, and here also this complete term will become 0. Why? Because there is no prestress. Then formula will be half root of 4 tau v square. 4 tau v square. We don't know what is tau v. That we need to determine. Tau v is equal to already we know the formula. Tau v is equal to v first moment of area divided by moment of inertia into b. For rectangle, most of the designs will be for rectangle section. That's why I am mentioning the formula directly. 3 by 2 v by bh. This is the formula for shear stress in rectangular beams. See, 3 by 2. Here the force is given. Force is supported, right? It is a simply supported. For simply supported beam, shear force will be WL by 2. W value is given as 5 kN per meter. Length is given as 10 by 2. 25 kilonewton. 25 kilonewton. Means V is 25. Breadth is given as how much breadth is given? Breadth is given 120 mm. 120 mm. Now I am converting it kilonewtons into newtons. 120 breadth, height is 300. Now the answer is that 1.05 Newton per mm square. This is the tau v. Now we will substitute this tau v here. 1 by 2 root of 4 into 1.05. Now the answer is that 1.05 Newton per mm square. Okay, this is the answer. Okay, now we will take plus or minus only. We will see later. Okay, this is the way to determine the principal tension force in the member. With prestressing force, with prestress. Now F max F minimum is equal to Fx plus Fy by 2 plus or minus half of the root of Fx minus Fy whole square plus 4 tau v square. That is equal to now we need to determine the axial stresses. Now we need to determine the axial stress. Axial stress is nothing but force by area. Force is given as how much axial force is given? It is given as 180 kilonewtons. 180 into 10 cube newtons divided by area. Area is 120 by 300 rectangular section. Now this force will be 5 Newton per mm square. 5 Newton per mm square. See, here there is no eccentricity. Y component will be 0 here. Y component will be 0. Already we discussed in the last video. Y component will be 0. There will be a pure. Earlier we have only shear. Now due to prestress we may have only Fx. Fy, there is no Fy here. Fy is 0, right? right. Now we will substitute these values in this equation. Fx is 5 by 2 plus or minus half of 5 square plus 4. What is the tau value here? Tau value is already we calculated 1.05. 05 square. The answer is that answer is equal to plus 5.23 Newton per mm square for compression minus 0.23 Newton per mm square. It is tension. It is tension. Now, how much tension force is developed? It is earlier 1.05, right? Earlier it is 1.05, now it is 0.23. Now we will calculate the percentage. Hence, with axial prestress, maximum principal tension is reduced by how much percentage? Earlier it is 1.05 minus 0.23 divided by 1.05, that is equal to into 100, that is equal to 78% of tension has been reduced due to prestressing.